Hello, sixth graders. We are going to be working on lesson 6-4. So if you're following along in your workbook, you're going to be on page 355. So if you could turn to page 355 in your workbook, you're going to follow along with me. All right, so this lesson is about estimating to find percent. So we all know that estimation is an incredibly important and powerful math tool to make sure that we understand the concept, we understand what's going on. Estimation is really important. So we're going to be working on that today. This first warm-up question introduces us to Sarah, and she would like to score a 78% on her next test. She knows that the test will have 40 questions. So I'm sure you guys are all thinking what I'm thinking, which is that this is kind of a silly introduction to a problem because I would assume that, no one would shoot for less than 100. You would think Sarah would just try and get every problem right, and that's really the best you can do on any test is try and get as many right as you can. Hopefully she wouldn't get 5 right and stop there and say, oh, I got my desired score, now I'm going to bomb the rest. But anyways, this is the problem we're given, so we're going to try it. So we're being asked to use this grid here, which represents the number of problems. So they're saying there's 40 questions on the test, and you're given, 1 through 40, and the idea would be that each of these rectangles is representative of one question on the test. So I want you guys to try and use the model to help you solve the problem, and remember again that this whole lesson is about estimation, so it doesn't necessarily have to be an on-the-dot answer. I want you to think about how you could figure out roughly how many questions Sarah will have to answer correctly in order to hit her 78% goal. Alright, so I'm going to pause the video, you're going to pause the video, you're going to try it, and come back for answers. Okay, friends, so I have marked up my screen a little bit, and it may look different than what you have on your paper, and if you chose a different way to solve this problem, of course, that is completely fine. So the way that I thought about it is roughly, I said if there are 40 questions in the entire test, on the test, that means that getting 40 correct would represent 100%. So if getting 40 correct would represent 100%, I knew that that meant that getting 20 correct would represent 50%. And I noticed actually here that I had 4 rows of 10. So if I were to divide 100 by 4, that would mean that each 10 questions is worth 25 points. So if I got 10 questions right, I get 25%, 20 questions right, I'd get 50%, 30 questions right, I get 75%, and 40 questions right, I get 100%. So I thought even a little further then that I could actually break down the points per question using mental math. So if each row of 10 questions is worth 25 points, that means 25, I can just divide 25 by 10 to calculate the amount of points per question. So 25 divided by 10, of course I'm just going to move the decimal place over 1 to the left, so I have 2.5 points per question. So I knew that 30 was kind of a benchmark here. If I got 30 questions right, I get a 75%. If I got 31 questions right, so 75 plus 2.5 is going to give us 77.5. So with 31 questions right, I'd get a 77.5. And then to get myself over that 78% mark that Sarah's looking for, I would have to answer 32 questions correctly. So you actually could have solved this problem down to the exact number of points using estimation. I just want to remind you guys, to be creative with your thinking. Remember that you can use division, multiplication, you can use fractions, decimals. You're not limited as to the tools that you can use. So you're taking all the math tools that you have with all these questions and using them all to your advantage. You're not limited to a specific set of tools. Okay? So we're going to go ahead and move on to our first example here. All right, so if you're following along with our examples, the next example number 1 is on page 356, so that's where you should be. And this is just going to walk us through an example of eye colors among 500 students at a school. So we're using the circle graph at the right, which gives us, the thing about circle graphs is that they always add up to 100%. Okay, so that means that everything inside this graph should add up to 100%, and the specific pieces of pie are showing us a percentage. So this is 16 over 100 of the total, and the total, if you added all these pieces together, should add up to 100 over 100, so 100%. Okay, so if we're looking at this, we're being asked to make some estimations here. So according to the graph, 46% of the students have brown eyes. So brown eyes is going to be this grayish blue color here. And what we're going to do, because we're estimating, is we're going to round. So what would we round 46 to? That's a nice benchmark percent. We're going to round it right to 50%. So if we have 500 total students and about 50% of them have brown eyes, that means about 250 students have brown eyes. We're going to do the same thing over here. We're looking at blue eyes. So now we're saying, according to the graph, 23% of students have blue eyes. Well, what is 23% close to? That's a benchmark percent. It's really close to 25%, which is equivalent to 1/4. So what's half of 250? Well, it's 125. So 1/4 of 500 equals 125. So about 125 students have blue eyes. Okay, so I want you guys to attempt to try it down here at the bottom of the page and meet me back here in a couple minutes for answers. All right, to review this problem, what I did was I rounded the 16% that's in our circle graph here. It says 16% of the students have green eyes. And all we're doing here is we're changing the total amount. So instead of talking about the 500 total students, now we're talking about the 120 students in the 6th grade. So I'm going to round this 16%. I rounded it to 20%. And if I round that to 20%, so 20% is 1/5 of 100%. So if 120 equals 100%, I want 1/5 of that. So I'm going to divide 120 by 5. 100 divided by 5 is 20. 20 divided by 5 is 4. 20 plus 4 equals 24. So we have 24 people would equal 1/5 or 20% of the 6th grade who would be representative of people with green eyes. Okay, let's go on to our next example. For example number 2, we're looking at using rounding and compatible numbers to make estimates. So in this problem, we're being asked, we're looking at the results of a certain survey about summer jobs. So students were surveyed about if they're going to have a summer job, and this says that 53% of 94 students surveyed plan to get a summer job. So how can we make an estimate as to what number of students would 53% of 94 students be? We're not looking to come up with an exact answer, we're looking to come up with an estimate. So one way is we could use rounding. So here on the left it says we could use rounding. 94, we're rounding to the nearest 10. So 94 is going to round down to 90. We're going to round 53 to 50%. We know that 50% is equivalent to 1/2, so we're going to multiply 1/2 times 90 to figure out what is half of 90. The answer is 45, so about 45 students plan to get a summer job. Another way is we could use compatible numbers. So here, instead of thinking, what is 94, how am I going to calculate 53% of 94 as it stands? I'm going to round this to 100, right, because 100 is a nice, and when we're talking about percent, of course, 100 is a beautiful number, because we can just say whatever the numerator is. So 100 is a compatible number for 94. 53%, and I'm not even sure why they would round this. They rounded this to 50 to say 1/2 of 100 equals 50, but if you're rounding to 100, you could even just say 53%, so the answer would be 53. But they're rounding this down. I guess it's going to get you closer to the actual answer if you round down. So they're going to round down to 50%, and they're going to say 50% of 100 is 50 students. Okay, so about 50 students plan to get a summer job. All right, I want you guys to attempt to try it down here and then come back for the answer. Right, friends, I have filled in the answers for the try it portion of this example. So go ahead, check your answers, pause the video, and we're going to move on to the next example. All right, friends, it turns out there's only 2 examples in this lesson. I forgot we usually have 3. So instead of moving on to another example, I'm going to have you guys try this page of the classwork. So this is on page 358. You're going to give this a try, pause the video, and come back for your answers. All right, friends, I have highlighted the answers in the video here for questions 1 through 9. I want you to go ahead, check these out, see how you did, and then when you are finished checking your answers here for the classwork, you're going to go ahead and move on to the Pearson Math Excel Extra Learning that I've assigned to you through the portal. Okay, so that's what you're going to do next. I want you guys to be sure if you have any questions, you're shooting me an email. Okay, we are going to have an opportunity. We're going to have a live class this week, so you are going to have an opportunity to ask some questions. And my thought is that we're going to use some of that time to go over the mid-topic assessment. Okay, So see how you do on this, check your answers, go on Pearson, pull up the Math Excel for lesson 6-3. No, is this 6-4? I'm sorry, I should know this. I'm doing all my videos in a row, I'm getting confused. This is 6-4. So when you're done with this, please go on Pearson and do the Math Excel Extra Learning for lesson 6-4. All right,